So there is a flight given to us. On flight from A to B, the details of that flight is track 153, TAS 210, distance from A to B 925, wind velocity 200 at 30, fuel on board 1000 pound, reserve 200 pounds, fuel consumption 180 pound per hour. What is the time and distance to critical point, time and distance to PNR, point of no return, and calculate still air range. We'll begin with critical point first. Okay, we will begin with critical point first. So let's calculate that. So let's draw a flight route. Very simple. We are starting from A. We are going towards B. A to B. So A, B. The total distance from A to B is 925 nautical miles. 925 nautical miles. Nautical mile. And the other questions, track, TAS, wind velocity. Now we are going to use this information of track, TAS, and wind velocity in CX3. Now for every critical point sum, you will have to draw a table. So that table will look something like this. From to, okay. After that, track, a column for track, a column for TAS, a column for wind velocity, and a column for ground speed. So a table like this you will have to draw. Fine. Okay. So next, in the column from first column, which is from and to. Okay, in that column you will have to write. You will have to write ground speed outbound. G for ground speed, O for outbound. So now here we will have to write three rows. We will have to make three rows. Now first we are going from point A. This is the total route A to B, and we are dealing with critical point. So let's draw a critical point somewhere here. Okay, critical point we have drawn there. Now what is the critical point? The point at which if our engines fail, it will be equal amount of time if you continue to Bravo, or you will take same amount of time to come back to departure A. So that place from where it will take equal time to go ahead to your destination or to turn back and come to your departure airport is a critical point, and we assume that at critical points our engines have failed. Okay, so that point. So first row, ground speed outbound from A to CP. From A to CP. So you're starting from A, you have taken off from departure A. All your two engines or four engine aircraft, all engines are working properly. Okay, there is no engine failure. Everything is working fine. And then you fly and come towards critical point CP. Okay, so this first ground speed outbound A to CP, all your engines are working normally. Next row you will have to write about ground speed outbound again, but from CP to B. So this second row will consider that route of flight from CP towards B, Bravo. So here at CP we are considering that our engines are failed, and after engine failure the pilot has decided to continue to destination Bravo. Okay, so this is the row for that route of flight. Next, last route you will have to make of ground speed homebound. Now over here it was OY outbound, okay, because we are going outbound. Outbound means what? Going away from your departure, okay, departure location. H means homebound. So at critical point where your engines have failed, the pilot has made a decision to come back to your departure airport, which was point A. So you are coming back to your home. Okay, so that's why this is called ground speed homebound. Is will be starting from CP, and at CP you make a decision to come back to point A. So this is CPA. Okay, this is your diagram. Next, wind velocity. What is the wind velocity coming from 230, 20030? So that means if this is your north pole, or if this is your northerly direction, straight up is your northerly direction. So everything here will be east, this will be south, and this will be west. So 200 is your southwesterly direction. Okay, that means winds are coming from somewhere here, like this. So that means when we start from A and when we fly towards critical point, we will be getting a little bit of tailwind. Now this is not a perfect tailwind. Okay, this is not a perfect tailwind because our track is what? 153. Okay, it is not a proper tailwind. So our track is 153 means we are going towards southeasterly direction. Southeasterly direction we are flying and our winds are coming from 200. So more of a crosswind and little bit of tailwind we can consider. Anyways, next point is, so that is our wind velocity. Now let's fill the diagram over here. Now over here in this diagram, you need not write track 153 or wind velocity, anything like that. But just to understand the ground speed, because your wind velocity will have an effect on ground speed. So when you add wind velocity to true airspeed or subtract it from true airspeed, you will get your ground speed. So that's why just for understanding. Okay, so when you will be going outbound from A to CP, there will be a crosswind tailwind. CP to B, again crosswind tailwind. But if you decide to come back towards A, CP to A, you will be getting a crosswind and a headwind. Okay, when you come back to your departure airport. So to understand that scenario, I have drawn the direction from where the wind is coming. So next, let's fill this diagram. Let's fill this table. So first, for ground speed outbound A to CP. Now, when you're going from A to CP, your initial track is A to B, which is 153. So A to B, your track is how much? 153. So when you're going from A to CP, when you're going from A to CP, your track will also be 153. Next, what is the true speed given to you? 210. What is the wind velocity given to you? It is given 200, 20030. 200 at 30 knots. They have asked you ground speed. So let's go to your CX3. Open your CX3. Okay. Go to option wind correction. Go to option wind correction. Now let's put our values. So a true airspeed of 210 knots. A true airspeed of 210 knots. So put 210, press the orange button, go down. Your course is 153, track is 153. Go to wind speed. Your wind speed is 30 knots. Wind direction is 200. Press the orange button. Now, where after pressing the orange button, you will get a ground speed of 188.39 knots. 188 decimal 39 knots. Okay. So let's make it 184. Let's consider this is 184. So let's write here. So ground speed will be 184. Let's go to next row. When you are going from critical point to B, okay. So critical point to B, the direction is what? 153. So write 153. Task is going to be the same. The wind velocity is going to remain same. So now let's put these values from CP to B. Again change all this. Task will remain same 210. Your true course will now again be remain same 153 because we are going from CP to B. Now heading over here is 159. Okay, wind speed is 30 and wind direction is 200. So same thing. So your ground speed after putting the same value, since these values are the same as the previous values, your ground speed again will remain the same. There is nothing to be changed here actually. So again, let's write it here. When you go outbound from critical point to point Bravo, your ground speed will be 184. Now let's come back. Let's come down to next row. You're coming back from critical point to point A. So when you come back from critical point to point A, you will be flying in opposite direction. So opposite of 153. That means reciprocal of 153. So use your calculator. Excuse me. Use your calculator and calculate the reciprocal of 153, which is 153 plus 180. A true course of 333. 333 degree. Task is again going to remain the same. Wind velocity is going to remain same. So let's put the new values in CX3. So task same 210. True course will be 333. Go down to wind speed 30 knots. Wind direction 200, 200. And now your new ground speed is 229.31. Okay. So let's make it decimal 3. So let's make it 230, 230. So with this we have completed a table. Going out when all engines are working, your A to CP is 184, CP to B, considering there is engine failure, take 184. If there is no engine failure, that's fine. Now when we go to next sums, okay, more and more, when we see more and more sums, the questions will become complex, in which they will give us two types of tasks. One task or one true speed in which all engines are working, so true SP is for that condition, and for another condition where there is engine failure. So when there is an engine failure, your true airspeed will decrease, so there will be another true airspeed value given to you for engine failure. So in that case, when we are dealing with CP, so considering engine failure at critical point, so from that point onwards you will consider task for engine failure. Okay, so whatever task is given to you for that engine failure, so you will use that. Now in this particular question, there is only one task given for everything, so you need not worry. For this is just a simple question to begin with, that's why. So from CP to B 184, and if you want to come back from CP to A, okay, after engine failure, your task should be less than 210. Okay, but in this question that's fine, just use what is given. So it is 230 knots. It is 230 knots. Next point. So next, now this is all your table with you. Okay. So we have to find distance to CP equals to how much? Distance to CP equals to how much? So distance to CP formula is dH divided by O plus H. Now in this thing, in this formula, D stands for this total distance 925 from A to B. So total distance from A to B. Okay, total distance from A to B. H. This H stands for the speed for homebound. Okay, ground speed homebound from from critical point. Okay, you are coming home back homebound or back home from critical point towards point A. So H stands for that speed. So in this formula for H you will use this speed 230. Next, O stands for speed. Now what kind of speed are we talking about? Ground speed, okay? So speed outbound from critical point. Speed outbound from critical point. So from point is critical point to point B. So ground speed is 184. Okay. So let's substitute the values. I will take a next slide. Okay, I will do it here. So distance to CP will be equal to DH O plus H. So that is equal to how much? D, which is total distance A to B. So total distance is 925 nautical miles. So let's put that 925 H. Speed homebound from critical point. From critical point, speed homebound is 230. So 230 divided by O plus H. What is O? O is speed outbound from critical point. So from critical point, speed outbound is 184 plus H 230. So this is equal to, use your calculator, 925 into 230 divided by 184 plus 230. So distance to critical point will be equal to 212,750 divided by 414, which is equivalent to approximately 514 nautical miles. So distance to critical point is 514 nautical miles. Okay. So this is your answer. Next, they have asked us to find out time to critical point. Now time to critical point, time formula is distance divided by speed. So distance to critical point divided by speed. Now in this case, you are calculating the time that you will take to go towards critical point. So in this case, you are going towards critical point from what point? From point A. So from point A to point critical point, how much time will you take? So for that you will require speed. So the speed that you will take is from point A towards point CP, critical point. So you will take the speed of ground speed outbound going from A to CP, going from A to CP. Okay. So let's substitute the values. What is DCP 514? What is the speed going from A to CP? It is 184. 514 divided by 184 is 2 hours 47 minutes. 2 hours 47 minutes. 2 hours 47 minutes. Okay. So this is how you have to do this sum. 2 hours 47 minutes. Critical point 514. So distance is this and time is this. 2 hours 47 minutes. Any doubts? So this is the whole scenario for your critical point. You first began from drawing simple diagram A to B, total distance, drawing a critical point anywhere midway. Then you have to draw a table for all critical point sums. The first one, you're going from A to CP. The speed for that. Substitute the values, calculate ground speed carefully. Then CP to B with an engine failure, 153 track task. So task given for the engine failure, we will do that sum, winds ground speed, and then critical point back to A, homebound. Okay, so why we have critical point to B and critical point to A is because at critical point we have to make a decision whether to continue to go to your destination or come back to your home airport. Either way, the time taken will be the same. After doing this, we calculated simple formula, substituted the values from here, ground speed values, and then answer came. So this is what it stands for. D is total distance A to B. H is your homebound speed. O is your outbound speed, both from critical point. So CP to A, CP to B. And time to CP is dCP divided by ground speed from A to CP. So value is 2 hours 47 minutes. So this is how you do the sum for CP. Now in RK Bali, the distance that they have given is 508 miles. And the time is given 2 hours 42 minutes something. So that's fine. The difference is not great. Okay. Now that might have been because here in this case I have rounded off the value. So instead of CX3, the ground speed was 183 decimal something. So instead of 183, I have taken 184. Here the ground speed was 229 decimal 3 something. So I have rounded off to the next higher digit 230. So because of this one increment that I have given at each place, final answer has increased from 508 to 514. Okay, so in the exam, even you do like I have done in the exam, you will have three options. So you can select any option which is closer to your value. Okay. Now, next part of the question is that we have to calculate the distance and time to PNR, point of no return. So let's go there. Now, this point of no return will also be solved in similar manner. Okay. Now, when you consider point of no return, there will be fuel element involved in that. Okay, fuel element. But before you do that, let's draw a table just like critical point. Now, when you are considering point of no return, you will have to draw a table with two rows. So I will show you same thing from and to here. Then one column for track, dash, wind, and ground speed, and ground speed. Okay, one for ground speed. Next. Okay, so first you are going from point A to point B. There is a point of no return here. So when you cross point of no return, let's say your aeroplane after taking off from point A has crossed this point of no return and it is somewhat here right now beyond point of no return. So once you cross point of no return and fly beyond it, you are bound to continue to your destination Bravo. Okay. So once you cross that point and you go ahead of that, you have to continue. You cannot return because if you decide to return, there will be insufficient fuel in your fuel tanks to take you back to your point A, which was your departure. If you are anywhere before point of no return, okay, you have not reached point of no return yet. You are somewhere before it. So at that point of time, you can make a decision to come back, to turn around and come back to point A. In that case, the fuel available with you will be sufficient to take you back to your departure location safely. Otherwise, no. Okay. So this is your point of no return concept. Now for this table, you will have to make two columns. In critical point, you made three columns. For this, you will have to make We will have to make how many columns? Two rows, two rows. So first your ground speed outbound from A to PNR. Okay, point A, that is your starting point to PNR. And next thing, ground speed, ground speed homebound, correction, ground speed homebound from PNR to point A. So you are calculating speed that you will require to go from A to PNR and then PNR back to A. So these are the two rows that you will make for this point of no return. Okay. Now let's fill this information. What is the track given to you when you go from A towards B? The track given to you was 153. So let's write that 153. The task was same 210. Wind velocity was 200 at 30 knots. Now what will be the ground speed? So let's put the values in your CX3. So true airspeed is 210. Your true course is 153. So put 153 there. Wind speed is 30. Wind direction is 200. So your total ground speed will be in this case 188.39. Okay, 188.39. So we can take it to be 188 or we can take it to be 189, whatever you want. So now we will take it to 188 only. We will not round it up to next higher value. So let's make this 188. Now let's fill the other row, the track. Now when you come back from PNR to back to A, so it will be a reciprocal direction. So what is the reciprocal of 153? 333. True airspeed is 210. Velocity is 200 at 30 knots. Correct? What will be the ground speed? So let's check the ground speed. So true airspeed is 210. Course is 333. Dash is 210. Let's put speed at 30 knots. Direction at 200 knots. So your ground speed is coming to 229.31. So let's take ground speed to be 229 knots. 229 knots. So we have filled a table now. Now let's go to formula directly. Now the formula for distance to PNR is how much distance to PNR equals to endurance into outbound speed into homebound speed divided by outbound plus homebound. Now here we are talking about echo, something related to E. Okay, E. Now this E stands for endurance. Endurance in hours. Okay. Now let's say you have 100 kg of fuel in your fuel tank. Okay. The fuel in your fuel tank, let's take an example, is 100 kg. 100 kg is what you have. And for every 1 hour, okay, for every 1 hour that you fly, you are consuming 10 kg. So that means out of 100 kg that you have, if you fly from 1 hour from point A to point B, you will consume or you will use 10 kg of 100 kg fuel. Okay. So how much time do you have to use all the fuel available to you? All the fuel available to you. So if you are using 10 kg in 1 hour, okay, you are finishing 10 kg of fuel in 1 hour. So you will finish 100 kg in how many hours? So cross multiply 100 divided by 10, that is 10 hours. So after flying for 10 hours, you will finish all the 100 kg of fuel. Okay. So again, a quick recap: you have 100 kg fuel. Fuel consumption means the rate at which you are consuming fuel. Whether you're consuming 10 kg per hour, 20 kg per hour, 15 kg per hour, so on and so forth. That is your fuel consumption rate. And after knowing fuel on board and fuel consumption rate, you can come to know or you can calculate your time. So the maximum time that you can fly with the available fuel, in this case you can fly a maximum of 10 hours. In 10 hours you will have finished all your fuel on the board. Okay, so this 10-hour time that is I have written here, this is called endurance. This is called endurance. So what is endurance? The amount of time aeroplane will fly with the amount of fuel available to it. Okay, या फिर the duration of time the aeroplane will fly with fuel on board. Okay, okay, fuel on board. So there is another term, flight fuel. So we will check that. But as of now, you can just understand that endurance is how much time that your aeroplane will stay in air with the fuel that it has. Okay, with the fuel that it has with itself. Okay. So out of 100 kg fuel, if it's going to use full 100 kg for its flight, so it will have to stay in the air for 10 hours. Out of 100 kg fuel, if it is using only 50 kg, the rest 50 kg out of 100 kg, 50 is using for flight, the rest 50 is just reserve. So that means another 50 kg of fuel you are not going to use. You are going to keep that as reserve fuel, extra fuel just for safety. For your flight from A to B, you only require 50 kg fuel out of total 100 kg. So in this case, your endurance will be how much? 50 divided by fuel consumption is how much? 10 kilograms per hour. 10 kilograms per hour. So 50 divided by 10 means 5 hours. So from going from A to B, okay, you have 50 kg of fuel that you require, and you can, with this 50 kg of fuel, you can stay in the air for 5 hours. So endurance is nothing but time, and time unit is hour, not minutes, not second. Always use hours. Okay, endurance is that. So endurance is equal to fuel on board minus reserve fuel divided by fuel consumption rate. Now, what is FOB? For those who don't know, the full form is fuel on board. This fuel on board is the total of the fuel that you will use to fly, flight fuel, plus any reserve fuel, extra fuel, contingency fuel, all those fuels. So fuel on board is the total fuel that you have. And what is uh, uh, RES? RES is reserve fuel that you have written here. RES, it is reserve fuel. This reserve fuel is only reserved in your fuel tanks. It is just going to lie down there. You will not use to fly from going from one place to another. You will not have to touch that fuel. Don't touch that fuel. So reserve fuel has to remain intact. Okay, you don't use that. So that is your reserve fuel. So when you subtract, an FC, as you know, is your fuel consumption rate of fuel consumption. Next point. So fuel on board minus reserve fuel is equal to your flight fuel. Is equal to your flight fuel divided by fuel consumption. So why flight fuel? Flight fuel is the fuel that you are going to use in your flight to go from one place to another place. Now you are not going to use your reserve fuel. So out of the total fuel on your board in your wing tank, you're subtracting the fuel that you're not going to use, reserve fuel, extra fuel, contingency fuel, so on and so forth. So the fuel that you're not going to use for your general flight from one place to another, you subtract that or you remove that from the total fuel available to you, and the remaining fuel which is available to you is your usable fuel or the fuel that you're going to use for your flight. So that's why we have flight fuel divided by fuel consumption. So finally, endurance formula is flight fuel divided by fuel consumption. Now in the questions that we are dealing, They won't give directly the flight fuel. They will give fuel on board and they will give you reserve fuel. It's your job to minus that and obtain flight fuel. Okay, so let's do it. Now in this question, they have given you fuel on board is how much? 1000 pounds. Fuel on board is 1000. Reserve fuel is how much? Reserve fuel is 200. 200 pounds. And always check that the units of every fuel element is same. They can give pounds for two things, and for the third thing they can give it in hour, kilograms, correction, kilogram per hour. So all the units of weight should be same. So reserve is 200. Fuel consumption is how much? It is equal to 180. Is equal to 180. So let's find out. Endurance equals to fuel on board minus reserve fuel divided by fuel consumption. Correct? Substitute the values. Endurance equals to 1000 minus 200 divided by 180. So 1000 minus 200 is 800 divided by 180. So endurance is equal to 800 divided by 180. So that is how much? 800 divided by 180 is 4 hours 26 minutes. 4 hours 26 minutes, or you have answer in decimal 4.4. 4.4. Now we will substitute this in your formula. So 4.4 into outbound speed 188 into homebound 229 divided by 188 plus 29. So distance to PNR so far will be equal to 191342 divided by 188 plus 229 417. So distance to PNR is 191342 divided by 417. So 458.8. So approximately 459 nautical miles. 459 nautical miles. So that is the answer that you have. 459 nautical miles. So therefore time to PNR will be how much? Distance to PNR divided by ground speed outbound from A to PNR. Okay, time towards PNR. So you're going from A to PNR, so use that speed. So 459 divided by 188 is equal to 2 hours 26 minutes. So the time taken to fly from A to PNR is 2 hours 26 minutes. Distance from A to PNR is 459 nautical miles. 459 nautical miles, and the time is 2 hours 26 minutes. Okay, so another big solution. So again, a quick recap. Draw two rows, one from A to PNR, another from PNR to A. Substitute the values. Track from going from A to PNR 153, but from coming back from PNR to A, the reciprocal of 153, which is 333. Okay, and then put the values in CF3 and get the correct ground speed. and after that put the values in the formula. And before that I explained to you in detail about endurance, which is fuel on board minus reserve divided by fuel consumption. So fuel on board minus reserve is flight fuel. Okay, so remember this clearly and don't forget this. And all units for fuel should be the same, kilogram. So everything should be in kilogram. If it's given in pound, everything should be in pound, so on and so forth. Now next thing we have to find is still air range, SAR, which is still air range. Still air range. The formula for it is fuel on board divided by fuel consumption into TAS. Okay. So still air means what? Air which is calm. No headwind, no tailwind, no crosswind. So in such air which is fully calm, there is no wind component in it. How far will you go in such an atmosphere which is calm when you use all the fuel available on board? So here we have fuel on board. So you don't have to subtract reserve fuel. You have to also use reserve fuel also. Okay. So fuel on board is 1000. The entire fuel. Okay. Fuel consumption is 180. Speed is 210. So still air range will be equal to 1000 into 210 divided by 180, which is 1166.6 nautical miles, approximately 1167 nautical miles. 1167 nautical miles. Okay, so this is how you calculate still air range. Fuel on board, all the fuel by fuel consumption into TAS, substitute the correct values, and this will be your answer. So with this, we have come to end of question 1, a very big question. Now in DGCA, they won't ask you to find all the three things. They will give you an information like this, and out of these three things, they will only ask you to find one thing, distance to CP, or they will ask only to calculate distance to PNR. Okay, only for only one thing. But since we are practicing now, we are going to find everything for our practice. Now let's go to next question. A similar question. A similar question. You're flying from A to B and your track is 250. Your dash is 195. Distance from A to B is 975. Winds are 300 at 35. Fuel on board 900 gallon. Reserve fuel 100 gallon. Consumption rate 150 gallon per hour. Calculate distance and time to CP, PNR and still air range. So let's deal with CP first. Now we will do a little faster. Always you're going from A to B. The total distance from A to B is how much? 975. 975 is your distance. There is a critical point between A and B. A critical point between A and B. So like I told you, for critical point you have to draw three columns, from and to column, a track column, a task column, a wind velocity column, and a ground speed column. Next, first point, you will be going from A to CP. So ground speed outbound from A to CP. Then you will be continuing outbound from CP to point B, so CP to B, and in case you want to come back from CP, you will come back to point A. So ground speed homebound from A to CP. So let's draw a table. Now let's substitute the values. Now going from A to CP outbound, your track is how much? 250. Your track is 250. Your true airspeed given to you is you have been given only one speed. So that speed you will use for all conditions. 195. Wind velocity is how much? 330 at 35. 330 at 35 is your wind velocity. Now let's calculate ground speed using CX3. So again, let's put the values. TAS is how much? 195. True course is how much? 250. Wind speed is 30 knots and wind direction is 330 knots. So your ground speed is 187.54. Okay, so we can take it 188. So we will take it 188. Wind speed is, let me check the wind speed, all the information. Wind speed is 3.5. Okay, so here put 3.5. 3.5, wind direction 330, true course 250, true airspeed 195 knots. So your answer is ground speed is 185.85 knots. Okay, so wind speed I put 30, it is 35. Ground speed now will be 185.8, approximately 186. So let's put 186 here, 186 knots, 186 knots. Now let's come to next row. You're going outbound from critical point, okay, from critical point to point number Bravo. So again the same point, your track will be 250, speed will be 195, direction will be 330 at 35. What will be your ground speed? So now see, this is the same. So ground speed will also remain the same, 186. Now something else will change. You're coming back from CP to A. CP, this is correction. Coming back from CP to A. So your direction of flight will be reciprocal of 250, right? So going from A to B, you are flying a direction of 250. So coming back from CP to A, there will be a direction which is opposite of 250, which will be 250 minus 180. 250 minus 180, which is 070 degree. So CP to A 070, true airspeed same 195, wind direction same 330 at 35. So your ground speed will be how much? Let's do CX3. So true airspeed is 195, true course is 70, wind direction 35, wind direction 330 correction, wind speed 35, and true course 70, 330. So your ground speed will be 198.01. So 198 knots, 198 knots, 198. So now we have all the values available to us. Let's use the formula. Distance to CP is D multiplied by H O plus H. Now D stands for total distance between A and B. So that total distance is 975 divided by into H. So H speed is homebound speed 198 divided by 198 plus outbound speed from CP to B, which is 186. So distance to CP will be equal to 975 into 198, 193,050. 198 plus 186 is equal to 384. So critical point distance will be 193,050 divided by 384, which is equal to 502.7. 502.7 nautical mile, approximately 503 nautical mile, approximately 503 nautical miles. Okay, next sum. Time to critical point. Time to critical point will be equal to distance to critical point divided by ground speed outbound from A to CP. Distance to critical point divided by ground speed outbound A to CP. So distance to critical point is 503. Ground speed outbound is 186. 503 divided by 186 is 2 hours 42 minutes. 2 hours 42 minutes. So in exam you will select an option which is close to this values. So we have done everything properly. We have put the correct values. We have used the formula for DCP. Multiply carefully, write that value, then add, write that value again, and then divide them both. So 503. Time to critical point is divided by ground speed outbound A to CP. Don't use ground speed outbound from CP to B. Okay, it's A to CP, and this is the value. Let's go to find PNR. Now for PNR, same thing. From and to, your track, your TAS, your wind velocity, and your ground speed. So you will be going outbound from A to PNR, and then you will be coming homebound from PNR to A. So this is your A to B outbound, PNR somewhere here. Okay, so for PNR you will do A to PNR, PNR to A. So now going from outbound A to PNR, your track will be how much? Same track 250. Your TAS will be 195. Winds will be 330 at 35. So what will be your ground speed? 1. Let's do it. 250. So TAS is 195. True course is 250. Wind speed 35. Wind direction 330. And TAS is 195. So ground speed is 185.85. You can take it to be 186. So 186. Next, coming back from PNR to A, you're coming back. So reciprocal direction of 250 will be 070, speed 195 TAS, direction 330 at 35. So your ground speed will be how much? 07. So TAS is 195. True course is 70. So after putting all the values, you get a ground speed of 198 knots. 198 knots. Okay, so that's it. Now let's calculate distance to PNR, which is endurance into outbound ground speed into homebound ground speed divided by GO plus GH. Now over here, endurance will be fuel on board minus reserve divided by fuel consumption. Correct? So fuel on board is how much? 900. Reserve is 100. Fuel consumption rate is 150. Endurance will be 900 minus 100, 800 divided by 150 equals to 5 hours 20 minutes. 5 hours 20 minutes. So put that values. 5 hours 20 minutes into outbound ground speed is 186, 198 divided by 186 plus 198. Distance to PNR will be equal to multiply the numerator 196,416 divided by 186 plus 198, 384. When you divide that, 384, you get your answer in 511.5 nautical miles. So that is your distance to PNR, 511.5 nautical miles. Next, time to PNR is distance to PNR divided by ground speed outbound A to PNR. So distance to PNR, let's take 511. Speed is 186. So time to PNR is 2 hours 45 minutes. 2 hours 45 minutes. Okay. So choose the option or select the option which is close to this two values. Distance 511, 510. Time to PNR 2 hours 45 minutes. Now let's go to next part in which we have to calculate still air range. Formula is total fuel on board divided by fuel consumption into TAS. Fuel on board is how much? 900. Consumption is how much? 150. Okay, fuel consumption rate is 150. True airspeed is how much? 195. So still air range will be 900 into 195 divided by 150. So answer is 1170 nautical miles. So still air range will be equal to 1170 nautical miles. So this is how you do the entire sum. Same, same way that we have done the previous sum. Now let's go to the next sum, which is again